Welcome. So let's move on to our next discussion board. And I want to start it off. I want to do a little bit of logic, but I really want to ask a question. And you can tell. I want all of you to go look in your book and look at the corresponding chapter on the portion on logic. If you all are feeling really good about predicate logic and propositional logic, we can totally skip through this and move on to other things, or we can spend some time on this because we're going to use logic a lot more, especially understanding how these different statements. So I'm just going to give a warm up assignment, and then I'm going to ask one of the questions on the discussion boards. How do you feel about logic? So you can kind of give me a little more feedback in terms of how you feel about it. So again, let's just go back to the basics of logic. A proposition is a statement that's either true or false. So let's look at all these statements and let's determine if they're a proposition or not. All cars are red. That is a proposition because it is true. I can definitively say all cars are red or all cars are not red. Led Zeppelin is the best band of all time. Okay, now this is an interesting one because this is actually not quite a propositional logic because it's a proposition because it kind of depends on who you ask on this thing. Some people would definitively say the answer to this is yes. Some would say no. We can still say it's a proposition, and it comes down to the opinion of the person as to whether that's true or false. But it's a statement that is either true or false. Now, collectively, can we agree to that? That's a whole different matter, but it is a statement that's true or false. Now, if I say if my name starts with the letter J, then my name is Joe. This is a statement that is true or false. And it again, you might be like, well, it depends. But can you think of a situation where your name starts with the letter J, then my name is Joe? Okay, I can come to an opposite example. I don't know, like Jackson. So there's something that breaks it, so it's obviously false, but then we can have a false example and we're good. It's either true or false. X squared is equal to 4. This is the proposition. It's a mathematical equation, proposition. The answer is no, because it all depends on what X is. So for this reason, it's not. There exists an X such that X squared equals 4. Now this one is a proposition because I'm just saying there's some X out there in the world. Now that opens it up, and now it has a chance to be true or false, and it's not dependent on what X is. I'm just saying there's some X that's true for. So this is the key thing. Little subtle changes like this make it true or proposition. Again, this is a proposition that actually is kind of a predicate, getting this as predicate because it's a proposition that all real numbers X squared equals 4. It's either true or it's false. It's true for every X or it's not true. Square root of 2 is an irrational number. Well, that is actually true, and we can easily state that one. P is prime. Again, we might assume P is a prime number. This is not a proposition because we don't know what P is, so we cannot test whether or not it is prime or not, and therefore we're stuck. All right, so as a quick reminder, by definition, a proposition is not true, if A is some proposition, not A is true when A is false. No, it's the negation. And again, we're gonna use this little symbol right here, this little not symbol. And we're gonna use the conjunction symbol, the little hat or mountain symbol. For disjunction or, we're going to use this little V symbol right here. This one is also called a wedge, by the way, in LaTeX. It's slash wedge. This is slash V. This is slash not. It's kind of funny. All right. And then if then is true if A and B are both true, or if A is false. In other words, it is false only if A is true and B is false. It's the only time it ever fails. This is an implication or conditional statement. So let's do a quick problem and let's interpret what does this mean. What does this mean? Not A and B. So if I say you're a math major and in your class, not A and B, all I have to do is make one of those false. So this statement right here actually comes down to, it's like saying saying not A or not B, because all I need is one of them to be, because I need this statement inside of here. If this statement inside of here is true, then this is going to be false automatically. So all I need is this to fail to be true. Remember, this fails to be true if either one of these or both of them fail to be true. On the other hand, over here, not A or B means it's not A and it's not B. So sometimes we use this terminology, not A or B, we're eliminating both A and B because it's not both of them. So we use these terminologies often. Be comfortable changing them, figuring out what they really mean and describe, because we're going to use them over and over and over again. So here are problems to do for the discussion board. Again, this should feel like common logic, but I just want you to practice doing some things. So I'm going to give you a couple of statements, and I want you to write these statements where A is 6 is an even number and B is 6 is a multiple 4. I want you to express them in sentences, English, and state whether they're true or false. That's it. Excuse me. And then I want you to create truth tables. Now, a truth table is, again, where we're just going to make a table about when it's true or false. So let's come back up here to this example here. If I want to make a truth table for this thing, up. So if I make a truth table, I'm going to have, I'm just going to make a nice long table. I'm going to have A and B right here. And then I'm going to have A and B. And then I'm going to have not A and B. Now, since I have A and B, this is going to be true and true, or this is going to be true and false, or this is going to be false and true, or both false. Now, in that situation, this would be true, false, false, false. So the not portion is going to make this false, true, true, true. Just flips the order of things. So this is a truth table, like I want you to do, for this particular logic. All right, so that's what you're doing, is these couple of problems. Again, I want you to write these ones, all 7 of these statements out. Then I want you to make the truth tables for 1, 2, 3, 4 of these. And finally, I want you to look at this one and determine when is this, can the player say that a coach has lied to them? You might want a truth table. And then last but not least, how can you prove that not A is the same thing as A? So those are a couple things I want you to tackle in this particular discussion board. I hope you're feeling better. And also, just, I'm going to give you one last question. How do you feel about propositional logic and predicate logic? Do you want to do more of it, or should we skip ahead to the other concepts that we have laying in wait for other ways to do proofs and so forth for this class that we can definitely get a little bit further?